Okay, today we will be taking T notes on friction. Friction is a force that is imparted by two bodies when they are in contact. It is a resisting motion and it is an opposing force to a motion. It happens when either one body slides over the other or the bodies cling together. This motion, this opposing force, acts in an opposite direction of that movement. It is directed parallel to the object's surfaces, and it causes objects to slow down or to stop.
Every surface has irregularities. They are jagged, peaks and troughs and dips. And these, when two objects collide and they scrape over each other, they give rise to a force that resists the motion. Depending on how many troughs and peaks there are, will dictate whether or not they have a high level of friction. And what causes this is electrostatic attraction between the atoms of the contact, which make it crash into each other and not allowing another object to slide over it.
There are two kinds of friction, static and kinetic. With static friction, it is when there is no relative motion between the bodies. So if you are pushing a block and it does not move, that force that keeps the things from starting to move, that is what static friction is. So here you see a block that is being applied with some force to the right. And in the opposite direction, because this box is in contact with the surface that it is sliding on, it is experiencing static friction. And this is denoted as F sub S, or you can spell it out static. Notice that this is in opposition to the applied force. We also do have the force of gravity acting on the box, and in its opposition, the support force, also known as the normal force or the force of reaction. Because all the arrows, all the vectors are equal, we have a net force of 0. The box is not moving. To make the object move, you have to overcome the force of static friction. And so you have to continue to push this box or pull this box. You must apply some force that will then eventually overcome the amount of static friction that this object is experiencing.
Imagine pushing a block. This is just an example. If you're pushing a block, it doesn't move, then you know that the friction must be equal but opposite to the pushing force. So here is where you have static equilibrium. You have the friction matching the applied force. As you push harder, the object is still not moving. The friction force grows with the pushing force. So as you continue to push, the friction will match the push until the block just starts to move.
Once the block begins to move, the friction force goes down considerably. This is now called kinetic friction. Now the friction that is in the opposite direction of the applied force is called a different name. So if the same force is applied that was used to start the block moving, the block will now begin to accelerate.
Here is a graph that shows the amount of force applied in relation to the amount of friction that is experienced. So here it starts with 0. As you increase the amount of applied force in newtons, the amount of friction also increases until it reaches a point where the object begins to move. What you'll notice is at this threshold of motion that it drops, and then you're able to accelerate or just keep a constant velocity for your object that you're moving. But it does take a certain amount of force in order to push it past the threshold at which the object will begin to move.
So let's take notes on kinetic friction, also known as dynamic friction. It is when two surfaces move past each other, and it is when you are pushing on the object and it is moving. Remember that when the object is in motion, that friction is weaker than static friction. Here we have our box with the applied force to the right, and the kinetic friction is much smaller than the applied force. Because the vector is greater, in the direction of the applied force, the net force is to the right, acceleration is also to the right. There are 4 factors that can affect friction. The first factor is texture or material. Rough surfaces tend to create more friction. For example, sandpaper, road or asphalt, and even tires due to the tread. So these rough surfaces will cling to the other surface and therefore creating a higher level of friction. Smoother surfaces, without as many dips and holes, these tend to create less friction. For example, we have some material over here like silk. We also know that glass is pretty smooth and so is ice. The second factor is surface area. The more surface area there is between the 2 objects results in an increase of friction. For example, we have tires of different sizes. The wider that the tire is, the more friction there will be because there is more traction. So if you look down here, you don't have to copy this or draw this, but road bikes have the least amount of friction because there is less surface area between the tire and the road. As you go further along, for example, if you have mountain bikes, then you would actually need to have more friction in order to brake. Now, there are other circumstances where we have a higher level of surface area. And for example, that is with air resistance. The size of your parachute. The larger the parachute, the more friction you will have in the form of air resistance. This can also be seen with the resistance of an object as it is gliding through water. For example, the size of the boat. The larger the boat, the more resistance from the water there will be, and that is a form of friction. The third factor is called load, and load is just a force that is exerted onto a surface. It causes an increase in friction, and this is because the more force that you put on an object, the more surface area that is touching between the 2 objects, which is then creating more friction. If you look down here and let's say that there was not as much force placed on a piece of rubber that is in contact with the road surface, notice the spacing between the 2 objects and how much of the 2 objects is touching. If you were to increase the amount of force that is placed upon that object, then what you would create is fewer spaces. When you have more surface area that is touching, that is going to create more of a clinging effect, and then the objects will be less likely to move. The fourth factor is lubrication. Lubrication reduces the effects of friction by filling the gaps that are in the surface of the materials. For example, here are 2 materials, and we know that there are troughs and crevices and very uneven surfaces, right, for both objects. What lubrication does is to fill all of these gaps so that the 2 objects are not touching or not touching as much. Therefore, they're able to glide over each other more easily. With the example of an engine in your car, without this lubrication, moving parts of the machine would slow down or it would stop very quickly.
All right, we've made it to the end. Hopefully everything makes sense, and we're going to practice this in class next. Have a wonderful day.